Good evening, students. Today's subject is theory of machine. Uh, Today's lecture is based on introduction of theory of machine, subject for diploma third year students. In this lecture, we will discuss what is the syllabus of this subject, and after that, we will discuss some topics in unit number one. There is 5 units in this subject. Okay. Now, come to the topics and syllabus of this subject. Theory of machines, and the code of this subject is WDME 501 for diploma third year students. There are 5 units in this subject, around 20 to 22 lectures I am taking for this completing this syllabus. The first unit in this subject is introduction, definition of statics, kinetics, kinematics and dynamics. What is kinematics and dynamics? And there are two subdivisions of the dynamics of theory of machine parts. This is statics and kinetics. We will discuss about what is rigid body and resistant bodies, what is links. After that, we will discuss about the kinematic pairs and their types, degree of freedoms, how to calculate the degree of freedom of a mechanism, planar mechanism, and after that, we will discuss about what is the kinematic chains and their types. And the last topic of this unit is constant motion and mechanism. What is constant motion and mechanism? What is mechanism? Okay. In second unit, mechanisms. Firstly, we will discuss classification of mechanism, and we will discuss about what is equivalent mechanism. And after that, next topic is the law of inversion of mechanisms. And after that, single slider crank chain and its inversions. After that, inversion of mechanism, we will discuss about the inversions of mechanisms. So there are three type of mechanisms for which we will discuss the inversions. Okay, forward mechanism, single slider crank mechanism, double slider crank mechanism. Uh, After that, we will discuss uh, what are the main inversions of these mechanisms, like Scotch York mechanism, indicator mechanism, pantograph mechanism, steering gear mechanisms. Okay, single threaded crank mechanisms, may IC engines, quick return motion mechanisms. So we will discuss about the inversions of mechanism in this chapter, in this unit. Now come to the unit number 3. Unit number 3 is based on brakes and dynamometers. Brakes are used to uh, reduce the speed of the vehicle. Okay, and there are many types of brakes. So in this unit we will discuss the working of the brakes, different type of brakes like uh, block, shoe brake, band brake, disc brakes, internal expanding brakes, power brakes. Okay, so and after that, in second part of this unit, we will discuss the working of the dynamometers and classification of the dynamometers. Dynamometers are used to determining calculating the uh, output, power output of a output shaft power. We can calculate the uh, power of a output shaft of any engine with the help of a dynamometer. Okay, there are many type of dynamometers: brake rope dynamometers, hydraulic dynamometer, Prony dynamometers. So in this topic, we will discuss the working and classification of the dynamometers, which are used for the calculating the powers of the output shaft of a engine. Okay. In this unit, there other part is clutches. So clutches are used to deattach the, yeah, or disconnecting the engine shaft from the transmission shafts. Okay. uh, Clutches are used in automobile and other machines and mechanisms. So what are the principle of work principle and working of the clutches? Single plate clutch, multi plate clutch, and cone clutch. So in this topic we will discuss about the working and the principle of the clutches, different type of clutches. Okay. Now come to the unit number 4. In this unit, uh, first topic is cam. Camshafts are used in internal combustion engine and other machines. These are mechanical timers. Okay, mechanical timers. So cams are used uh, for specific motion of any component in a machine. Okay, specific motion. Okay, uh, a specific word, or say uh, calculated, pre-calculated motion of any mechanism, of any link in a mechanism or machine. Okay, there are different type of cams used in the machines. Okay, generally cams are used in internal combustion engines for opening and closing the inlet and outlet valves of the engine. Okay, so in this topic we will discuss how a cam profile will design and different type of classification of cams and working of the cam. Second topic in this unit is flywheel. Flywheel is used for, are used for uh, store the energy of a extra energy of the engine. uh, okay, and after that this extra energy, stored energy in flywheel will use in another cycle of the engine. Okay, generally flywheels are used in machines, in internal combustion engines. Okay, so what is the working of flywheel and how to calculate the energy uh, storing and it maybe transferring. Okay, system in flywheel. Governors, in this last topic of this unit is governors, very important topic. So governors are used to control the speed of an engine. Or say the governors are used to operate an engine on a constant speed. Okay, for varying loads. Now come to the last topic, which is last unit. In last unit we will discuss gears, functions and classification of gears, nomenclature for gears. Gears are used in gears are used for varying the rpm and torque of any engine. Okay, so in this topic we will discuss about function and classification of the gears. After that, second topic in of last topic of this unit is power transmission devices like belt, rope, chain drives, etc. Okay, this is the whole syllabus of this subject. We will cover these topics in this subject. Okay, approx 20 to 22 lectures, in 22 lectures. Okay, we will prefer the book for this subject is S.S. Ratan, Tata McGraw Hill, Theory of Machines. Okay, you can prefer this book for covering these topics. Okay, now come to the unit number 1, Theory of Machines. Hello, Theory of Machines. The subject theory of machines may be defined as that branch of engineering science which deals with the study of relative motion between the various parts of a machine and forces which act on them. The knowledge of this subject is very essential for an engineer in designing the various parts of a machine. So in this subject, in theory of machine subject is related to the uh, relative motion between the various parts of a machine, okay, and the force acting on them. How to force, how we calculate, how the force is transferred from one link to the other link in a machine or in a mechanism, okay. Theory of machine is subdivided into two parts: kinematics of machines and dynamics of machines. Kinematics of machine, it is that branch of theory of machine which deals with the relative motion between the various parts of the machine. So in this part so in this revision, in this branch, kinematics of machines, we will only discuss, or we will only study the motions, relative motions of the links of various of links of a machine. Okay, okay, one in or we can say that how a link move relative to the other part, or how a link uh, moves related to the other part. Now come to the dynamics of machine. It is that branch of theory of machines which deals with the forces and their effects while acting upon the machine parts in motion. In this part of the theory of machine, we will deal with the forces and their effects on one component of a or one part of a machine. Okay. Dynamics of machines further divided into two parts: kinetics and statics. In kinetics, it is that branch of theory of machine which deals with the inertia forces which arises from the combined effect of the mass and motion of the machine part. Okay, while in statics, it is that branch of theory of machine which deals with the forces and their effects while machine are at rest. The mass of the parts is assumed to be negligible. Okay. Now, what is kinematic link or element? Before that, now after this topic, we will discuss about rigid link and resistant link. Each part of a machine which moves relative to some other part is known as kinematic link, or simply we can say link or element. In the diagram, a steam engine is showing in the diagram. So now comes to the right side of the engine. First part is crankshaft. Okay, crankshaft is used to uh, from the crank is connected with the crankshaft, and crankshaft rotates about the bearing along the bearings. Okay, now other part which is connected to the crankshaft is crank, and crank is further connected with the connecting rod. So from here, crank is a link, other link is connecting rod. Connecting rod is connected to the cross head, and cross head is connected with the piston rod. Okay, by the piston, and piston rod is connected to the piston. So here, cylinder is a one link, piston is another link is piston rod, other link is cross head, another link in this steam engine is connecting rod, crank, and crankshaft, and another link is flywheel. Okay, so each part of a machine which moves related to some other part is known as kinematic link. When the crank rotates, due to rotation of this crank, connecting rod transfer the motion to the crosshead. Crosshead reciprocates along the engine frame, and due to this reciprocating motion, piston the due to the reciprocating motion of crosshead, piston rod moves the piston which is connected with the crosshead. Okay, so the piston starts its relative motion, reciprocating motion between the dead centers in the cylinder. Okay, now we can reverse this motion from piston to crankshaft. Okay, when a pressurized fluid is inserted into cylinder, then piston starts moving from between the dead centers due to the reciprocating motion of the piston. Vice versa, final motion, final rotation will get at the crankshaft. Okay, and we can use this motion for any uh, work. Okay, now link or elements need not to be a rigid body, but it must be a resistant body. What is rigid body? Rigid body is a body on which there is no relative motion between the two points of the rigid body. Okay, Well, अगर हम किसी भी एक ऐसी बॉडी जिस पर फोर्स किसी भी अमाउंट का फोर्स अप्लाई अगर हम करते हैं, इफ़ वी अप्लाई एनी अमाउंट ऑफ फोर्स ऑन ए रिजिड बॉडी, देन देयर इज नो रिलेटिव मोशन बिटवीन टू पॉइंट्स एग्जिस्टिंग ऑन द रिजिड बॉडी ड्यू टू दैट एक्सटर्नल फोर्स। एक ऐसी बॉडी जिस पर किसी भी फोर्स को अप्लाई करने से उसके उस पर दो पॉइंट्स के बीच में कोई भी रिलेटिव मोशन नहीं होता है, तो ऐसी बॉडी को हम रिजिड बॉडी कहते हैं। ओके, एंड व्हाट इज रेजिस्टेंट बॉडी? इन actual world there is no rigid body. Each and every component or every material will deform at some point. Okay, किसी न किसी पॉइंट पर जाकर कोई भी मटेरियल या बॉडी डिफॉर्म हो जाते हैं, तो वो कोई भी मटेरियल या बॉडी एक्चुअल में रिजिड बॉडी नहीं होती, क्योंकि किसी न किसी पॉइंट पर जाकर डिफॉर्मेशन हो ही जाता है उनमें। तो यहाँ से एक कॉन्सेप्ट आता है रेजिस्टेंट बॉडी का। रेजिस्टेंट बॉडी, ए बॉडी इज सेड टू बी ए रेजिस्टेंट बॉडी इफ इट इज कैपेबल ऑफ ट्रांसमिटिंग द रिक्वायर्ड फोर्स with negligible deformation. ओके, रेजिस्टेंट बॉडी मीन्स एक लिमिटेड फोर्स के बीच में कोई एक लिमिट तक एक फोर्स अगर आप अप्लाई कर रहे हैं मशीन कंपोनेंट्स पर, तो उस लिमिटिंग फोर्स के अंडर में बॉडी एज ए रिजिड बॉडी बिहेव करती है, कोई डिफॉर्मेशन नहीं होता। तो इस तरह के बॉडी को हम रेजिस्टेंट बॉडी कहते हैं। नाउ thus a link should have the following two characteristics: it should have relative motion and it must be a resistant body. So for a machine component, machine part, or a link of a mechanism, two characteristics are required. First is it should have relative motion. एक link दूसरे link के respect में motion, उसमें relative motion होना चाहिए। और दूसरा है कि वो एक resistant body होना चाहिए। Okay? Now next topic is types of links. In order to transmit motion, the driver and the follower may be connected by the following three types of links. First type of link is rigid link. A rigid link is one which does not undergo any deformation while transmitting the motion. Strictly speaking, rigid links do not exist. However, as the deformation of a connecting rod, crank, etc., of a reciprocating steam engine is not appreciable, they can be considered as rigid links. Okay, so resistant link or a rigid link, first type of link. Second type of link is flexible link. A flexible link is one which is separate, partially deformed in a manner not to affect the transmission of motion. For example, belt, ropes, chains. So these type of links are flexible link. And the third type of link is fluid link. A fluid link is one which is formed by having a fluid in a receptacle and the motion fluid in a receptacle and the motion is transmitted through the fluid by pressure or compression only. As in the case of hydraulic presses, jacks and brakes. Okay, fluid links are used in hydraulic jacks, hydraulic presses, and hydraulic brakes. The three type of links are used. Now come to the next topic, which is structure. What is structure? It is an assemblage of a number of resistant bodies known as members having no relative motion between them and meant and carrying loads having straining action. A railway bridge, a roof truss, machine frames, etc. are the example of a structure. Next topic is difference between machine and a structure. The following differences between a machine and a structure are important from the subject point of view. First, the parts of a machine moves related to one another, whereas the members of a structure do not move related to one another. Okay. Second difference between the machine and the structure is a machine transforms the available energy into some useful work, whereas in a structure no energy is transformed into useful work. Now the third difference between the machine and a structure is the links of a machine may transmit both power and motion, while the members of a structure transmit forces only. Okay. Now come to the next topic, which is kinematic pair. Okay. The two links or elements of a machine when in contact with each other are said to form a pair. Again, the two links or elements of a machine when in contact with each other are said to form a pair. If the relative motion between them is completely or successfully constrained, the pair is known as kinematic pair. First, as in the case of a steam engine, crank is connected with the connecting rod. Yes. In this steam engine, crank is connected with the connecting rod. So crank and connecting rod is the kinematic pair. Okay, because crank and connecting rod has relative motion with each other, and in this case the motion is constant motion, completely constant motion with respect to each other. Either crank is rotated, then crank connecting rod will move in exact direction. If connecting rod move in some direction, then crank will rotate with respect to the connecting rod. Okay, with respect to the crankshaft. Okay, so the two links or elements of a machine when in contact with each other are said to form a pair if हम कह सकते हैं कि एक मशीन में दो लिंक काइनेमेटिक पेयर होंगे अगर यदि अगर उनके बीच में रिलेटिव मोशन हो जो कि कंप्लीटली कंस्टेंट मोशन हो या फिर सक्सेसफुली कंस्टेंट मोशन हो. ओके. First of all, let us discuss the various type of constant motions. अब हम सबसे पहले कांस्टेंट मोशंस के बारे में डिस्कस कर लेते हैं कि व्हाट इज कांस्टेंट मोशंस. ओके, सो फर्स्ट टाइप ऑफ कंस्ट्रेंड मोशन इज कंप्लीटली कंस्ट्रेंड मोशन. एक लिंक दूसरे लिंक के रिस्पेक्ट में जो मोशन कर रहे हैं, तो उसमें किस तरह का मोशन है. कंस्ट्रेंट मीन्स होता है रिस्ट्रिक्शंस. ओके, किस तरह का रिस्ट्रिक्शंस हैं. फ्री मोशन नहीं होना चाहिए. देखिए, एक कंपोनेंट से दूसरे कंपोनेंट के बीच में मोशन है, तो ऐसा नहीं होना चाहिए जैसे आपने एक मोशन कनेक्टेड नहीं है. रिलेटिव मोशन हो सकता है कि एक लिंक दूसरे लिंक को ट्रांसफ़र करे मोशन, और वो कनेक्टेड ना हो और वो फ्रीली किसी भी डायरेक्शन में मूव कर जाए. तो ऐसे लिंक्स को जो रिलेटिव मोशन रखते हैं उसे हम यहाँ पर काइनेमेटिक पेयर की कैटेगरी में नहीं रखेंगे. तो कंस्टेंट मोशन होना आपकी रिक्वायरमेंट है, तभी वो काइनेमेटिक पेयर्स कहलाएंगे. तो यहाँ पर कंप्लीटली कंस्टेंट मोशन का मतलब हो गया कि आपने एक पार्ट को अगर मोशन दूसरे पार्ट में ट्रांसफ़र किया, तो उसका जो मोशन है वो सिर्फ एक पर्टिकुलर डायरेक्शन में ही होना चाहिए, चाहे किसी भी डायरेक्शन पे फोर्स अप्लाई करें. ओके, व्हेन द मोशन बिटवीन ए पेयर is limited to a definite direction, irrespective of the direction of force applied, then the motion is said to be a completely constrained motion. Okay, when the motion between a pair is limited to a definite direction, irrespective of direction of force. आप किसी भी डायरेक्शन में फोर्स लगाएं लिंक पर, लेकिन जो मोशन होगा दूसरे के रिस्पेक्ट में, दूसरे लिंक के रिस्पेक्ट में उस लिंक का, वो डेफिनेट होगा, एक ही डायरेक्शन में होगा. हमें पता होगा कि उसका डायरेक्शन कहाँ है. तो ऐसे मोशन को हम लोग कहते हैं कंप्लीटली कंस्ट्रेंड मोशन. आप यहाँ पर देख सकते हैं नीचे एग्जाम्पल में, लेफ्ट साइड में यहाँ पर एक स्क्वायर होल है एक ब्लॉक में, और उसमें हमने एक स्क्वायर बार को फिट किया हुआ है. अब आप इसमें किसी भी डायरेक्शन में स्क्वायर बार पे फोर्स लगाइए, ये स्क्वायर बार सिर्फ लीनियर मोशन करेगा विद रिस्पेक्ट टू दिस ब्लॉक. ठीक है, समझ में आ रही है आपको ये बात. सो दिस टाइप ऑफ मोशन इज कंप्लीटली कंस्टेंट मोशन. यूनिक डायरेक्शन में, एक सिंगल डायरेक्शन में आपका मोशन हो रहा है रिलेटेड टू द अदर लिंक. कम टू द सेकेंड डायग्राम. यहाँ पर एक हमारे पास ब्लॉक है जिसमें सर्कुलर होल है, उसमें से एक शाफ्ट इंसर्ट किया गया है जिसके दोनों साइड में कॉलर है. कॉलर की वजह से ये शाफ्ट लीनियर मोशन नहीं कर सकती विद रिस्पेक्ट टू द ब्लॉक. ये इसमें से मूव नहीं कर सकता. सिर्फ एक ही टाइप का मोशन हो सकता है, वो है रोटेशन. यहाँ पर सिर्फ और सिर्फ रोटेशन हो सकता है, और दूसरे टाइप का कोई भी मोशन नहीं हो सकता. तो इसे हम कहेंगे कंप्लीटली कंस्टेंट मोशन. ये भी हमारा किस कैटेगरी में आएगा, कंप्लीटली कंस्टेंट मोशन की कैटेगरी में आएगा. नाउ सेकेंड टाइप ऑफ कंस्टेंट मोशन इज इनकम्प्लीटली कंस्टेंट मोशन. यहाँ व्हेन द मोशन बिटवीन ए पेयर कैन टेक प्लेस इन मोर देन वन डायरेक्शन. एक से ज़्यादा डायरेक्शन में अगर किसी लिंक का मोशन हो दूसरे लिंक के रिस्पेक्ट में, then the motion is called an incompletely constrained motion. Okay, the change in the direction of impressed force may alter the direction of relative motion between the pair. आप फोर्स किस तरह से अप्लाई करते हैं उस पर डिपेंडेंसी होगा कि किस जो मोशन है बॉडी में, लिंक में, वो किस टाइप का होगा. यहाँ पर एक एग्जांपल है कि एक ब्लॉक है जिसमें सर्कुलर होल है. ओके, इसमें से एक शाफ्ट को इंसर्ट कर दिया गया है. ये शाफ्ट इसमें सर्कुलर मोशन भी कर सकती है विद रिस्पेक्ट टू द ब्लॉक, और लीनियर मोशन भी कर सकती है, या दोनों मोशन एक साथ भी हो सकते हैं. इट डिपेंड्स कि फोर्स की जो डायरेक्शन है वो किस डायरेक्शन में आप फोर्स अप्लाई कर रहे हो. अगर इस शाफ्ट की एक्सेस के अलोंग हॉरिजॉन्टल फोर्स अप्लाई किया जाए, फोर्स की लाइन ऑफ एक्शन हॉरिजॉन्टल हो और इस शाफ्ट के एक्सिस के अलोंग हो, तो जो मोशन होगा इस शाफ्ट का वो लीनियर मोशन होगा। अगर आप इस एक्सिस के, शाफ्ट की एक्सिस के से एंगल पर फोर्स को अप्लाई करते हैं शाफ्ट पर, ओके, या आप परपेंडिकुलर अप्लाई करते हैं फोर्स को, तो इसमें लीनियर मोशन ना होके ये फोर्स है यहाँ पर जो मोशन होगा शाफ्ट में वो रोटेशनल होगा, रोटेशन स्टार्ट हो जाएंगे। और अगर किसी एंगल पर अगर आप फोर्स अप्लाई करते हैं तो रोटेशन भी होगा एज वेल एज लीनियर मोशंस भी आएंगे। तो दिस टाइप ऑफ मोशन of a link with respect to other link is known as incompletely constrained motion. Now, third, successfully constrained motion. When the motion between the elements forming a pair is such that the constrained motion is not completed by itself but by some other means, then the motion is said to be successfully constrained motion. अगर हम किसी लिंक का मोशन एक्सटर्नल फोर्स को अप्लाई करके कंप्लीटली कंस्टेंट मोशन में कन्वर्ट कर सकें तो ऐसे जो मोशन को, लिंक के मोशन को सक्सेसफुली कंस्टेंट मोशन किया जाता है। तो इसमें हमें फोर्स की रिक्वायरमेंट होती है, एक्सटर्नल फोर्स की, तब आपका जो मोशन होता है लिंक का वो कंस्टेंट सक्सेसफुली कंस्टेंट मोशन में कन्वर्ट हो जाता है। यहाँ पर एक फुट स्टेप बेयरिंग है हमारे पास, उसमें एक शाफ्ट है, शाफ्ट के ऊपर से अगर लोड अप्लाई करेंगे तो लीनियर मोशन तो ब्लॉक हो गया, शाफ्ट सिर्फ आपका इस बेयरिंग के अलोंग अबाउट रोटेशनल मोशन कर सकता है। अगर आप लोड रिमूव करेंगे और किसी डायरेक्शन में डाउनवर्ड डायरेक्शन से फोर्स लगाएंगे तो फिर लीनियर मोशन भी हो सकता है, रोटेशन भी आ सकते हैं। तो ये आपका सक्सेसफुली कांस्टेंट मोशन में कन्वर्ट होगा if and if the load is applied down in downward direction on the shaft. Okay, the topics, okay, definition of statics, kinetics, kinematics and dynamics ये हमने डिस्कस कर लिया। रिजिड बॉडी और रेजिस्टेंट बॉडीज क्या होते हैं ये भी हमने डिस्कस कर लिया। लिंक्स क्या है ये भी हमने डिस्कस किया। काइनेमेटिक पेयर्स और कंस्टेंट मोशन के बारे में हमने यहाँ डिस्कस किया कि कंस्टेंट मोशन क्या होते हैं। नाउ काइनेमेटिक पेयर्स के लिए डिस्कशन कर लेते हैं कि व्हाट इज काइनेमेटिक पेयर्स। ये एक थोड़ा इम्पोर्टेंट क्लासिफिकेशन है। देखिए इस सब्जेक्ट में जो मेन टॉपिक्स हैं आपके, तो फर्स्ट पार्ट में थ्योरी ऑफ मशीन के फर्स्ट पार्ट में जो हम लोग डिस्कस कर रहे हैं वो मोशन स्टडी कर रहे हैं बेसिकली हम लोग, कि क्या मोशन है, कैसे मूवमेंट्स होते हैं, एक और क्या काइनेमेटिक लिंक है, काइनेमेटिक पेयर क्या है, तो ये हम लोग डिस्कशन इसमें करते हैं, है ना। और कंस्टेंट मोशंस क्या होते हैं ये हमने इसमें स्टडी कर रहे हैं इस पार्ट में। तो काइनेमेटिक पेयर्स की अगर हम बात करें तो हम डिस्कस कर चुके थे कि दो लिंक्स जिनके बीच में कंस्टेंट मोशन या सक्सेसफुली कंस्टेंट मोशन हो, तो रिलेटिव मोशन हो, तो ऐसे पेयर को, ऐसे लिंक्स को हम क्या कहते हैं, काइनेमेटिक पेयर कहते हैं। तो यहाँ क्लासिफिकेशन ऑफ काइनेमेटिक पेयर्स में द काइनेमेटिक पेयर्स में बी क्लासिफाइड अकॉर्डिंग टू द फॉलोइंग कंसिडरेशंस। ओके, फर्स्ट, according to the type of relative motion between the elements, लिंक्स के बीच में रिलेटिव मोशन के बेस पर हम लोग काइनेमेटिक पेयर के क्लासिफिकेशन कर सकते हैं। सेकेंड क्लासिफिकेशन इज अकॉर्डिंग टू द टाइप ऑफ कॉन्टैक्ट बिटवीन द एलिमेंट्स, एलिमेंट्स के बीच में किस तरह का कॉन्टैक्ट है। ओके, फिर नेक्स्ट है लास्ट, अकॉर्डिंग टू द टाइप ऑफ क्लोजर। ओके, किस तरीके से दोनों लिंक कनेक्ट क्लोज्ड हैं एक दूसरे के साथ, कैसे कनेक्शन है उनमें। तो ऐसे आप इन तीन बेसिस पर हम काइनेमेटिक पेयर्स को क्लासिफिकेशन कर देते हैं, कर सकते हैं. तो फर्स्ट इज अकॉर्डिंग टू द टाइप ऑफ रिलेटिव मोशन बिटवीन द एलिमेंट्स. The kinematic pairs, according to type of relative motion between the elements, may be classified as first sliding pair, second turning pair, third rolling pair, fourth screw pair, and fifth spherical pair. सो 5 टाइप से आप हमें से क्लासिफिकेशन कर सकते हैं यहाँ पर. तो फर्स्ट पेयर क्लासिफिकेशन स्लाइडिंग पेयर के किस तरह का होता है. When one link is slides with respect to the other link, this type of kinematic pair is known as sliding pairs. Okay, okay, sliding pairs. When one link is having a sliding motion along the other link, then the kinematic pair is known as sliding pair. When the two elements of a pair are connected in such a way that one can only slide relative to the other, the pair is known as sliding pair. Examples are first the piston and slide cylinder. Piston slides along the cylinder walls, okay, in a internal combustion engine or in steam engines. Crosshead and guides of a reciprocating steam engines. Ram and its guides in shaper machine. Tailstoke on a lathe bed, etc. are the example of sliding pair. A little consideration will show that sliding pair has a completely constant motion. Okay. Now see, here there is a rectangular block having a rectangular slot. A rectangular shaft is inserted in this block. This rectangular shaft only can slides along with this rectangular flex block. Okay, the motion of this shaft with respect to the fixed block is a sliding motion. Okay, so the this fixed block and this rectangular shaft makes a sliding pair. Simple. Now the second kinematic pair is turning pair. What is turning pair? When the two elements of a pair are connected in such a way that one can only turn or revolve about a fixed axis of the another link, the pair is known as turning pair. Okay, a shaft with the collars at both ends fitted into circular hole is the example of turning pair. The crankshaft in a journal bearing in an engine is also a turning pair example. Lathe spindle supported in headstock is also another type of turning pair. Cycle wheels turning over their axles, etc., are the example of a turning pair. A turning pair also has a completely constant motion. Now come to the diagram. Here a rectangular block having a circular hole and a shaft is inserted in this circular in this block, and the shaft having the collar at the both ends. So the shaft, so this due to this collars, shaft cannot move linearly along this fixed block. Okay, so as we can see in this diagram, the uh, combination of these two links having only a rotary motion along uh, with respect to each other. Okay, so this type of motion or kinematic pair is known as turning pair. Here one link only rotate along with respect to the other link. So this pair, these type of pairs are turning pair. Now what is rolling pair? When the two elements of a pair are connected in such a way that one roll over another fixed link, the pair is known as rolling pair. Ball and roller bearings are example of rolling pair. Now, what is rolling pair? See, in a rolling pair, rolling in a bearing, roller bearing, these balls rolls along the outer circumference of this inner bearing. Okay, so the motion of these balls with respect to the inner bearing surface is a type of a rolling pair. Is the type of a rolling pair. Now come to the next classification of the kinematic pair, which is according to the relative motion between the kinematic pairs, is screw pair. What is screw pair? When the two elements of a pair are connected in such a way that one element can turn about the other by screw threads, the pair is known as screw pair. The lead screw of a lathe machine with nut is an example of a screw pair, and bolt with a nut are examples of a screw pair. Okay, so what is a screw pair? In screw pair, one link has a rotational motion along with a linear motion. Specific linear motion is known as the screw pair. Here, this is the see this diagram. A screw having a rotational and a linear motion with respect to this fixed block having internal threads. Okay, so this is a screw pair. Now, the last classification of the kinematic pair, according to the relative motion to each other, is spherical pair. When two elements of a pair are connected in such a way that one element turns or swivels about the other fixed element, the pair formed is called a spherical pair. The ball and a socket joint is an example of a spherical pair. Attachment of a car mirror is also another example of spherical pair. Pan, stand, etc. are the example of a spherical pair. See in this diagram, this sphere is connected with a lever and is inserted into a uh, spherical hole in this fixed block. This lever, when we move this lever, then this ball can move in either in x direction, rotate in x direction, or either this ball can be rotated in y direction, or it can rotate in z direction. Okay, so this type of kinematic pair is known as spherical pair. Okay, now the second type of classification is based on the according to the type of contact between the elements. how one link is connected with the another link, how the one link is contacted with the other link, we can classify the kinematic pairs in two types. First is lower pair and the second is higher pair. Okay, lower pair and higher pair. The kinematic pairs according to the type of contact between the elements may be classified as discussed below. First is lower pair. What is lower pair? When the two elements of a pair have a surface contact, when relative motion takes place and the surface of the one element slides over the surface of other, the pair formed is known as lower pair. It will be seen that sliding pair, turning pair and screw pairs form a lower pair. Again, when the two elements of a pair have a surface contact, okay, when relative motion takes place, the surface of one element slides over this other another surface, the pair formed is known as lower pair. As in the case of a steam engine, piston slides along the cylinder walls, and the contact between the piston and the cylinder wall is the surface of the piston is connected with the uh, uh, cylinder walls. Okay, so this type of pair, kinematic pair, is a lower pair. Okay, now higher pairs, when the two elements of a pair have a line or point contact, when relative motion takes place and the motion between the two elements is partially turning and partially sliding, then the pair is known as higher pair. In the case of a cam and follower, only cam connected with the follower with a line contact, this type of pair is a higher pair. Okay, a pair of friction discs, tooth gearing, belt and rope drives, ball and roller bearings, and cam and follower is the example of higher. Okay, now come to the last classification based on according to the type of closure. The kinematic pairs according to the type of closure between the elements may be classified as self-closed pair and force-closed pair. Self-closed pair means when the two elements of a pair are connected together mechanically in such a way that only required kind of relative motion occurs, it is then known as self-closed pairs. The lower pair are self-closed pairs, and second classification of kinematic pair is force-closed pair. When the two elements of a pair are not connected mechanically but are kept in contact by the action of external force, the pair is said to be force-closed pair. The cam and follower is an example of force closed pair as it is kept in contact by the force exerted by the spring gravity. Okay, so we can classify the kinematic pairs by three based on three methods according to the relative motion between the kinematic pairs, according to the contact between the kinematic pairs, and according to the type of closure between the kinematic pairs. Okay, now we can see in this example here cam is inserted into the follower. It is a closed pair. Okay, and what is open pair? Here cam is in outside of the follower, and the cam rotates, follower moves up in reciprocating motion between this fixed block. Okay, now we will end this lecture, today's lecture. In this lecture we study what is definition of statics, kinetics, kinematics and dynamics, what is rigid body and resistant body length, what is kinematic pairs and classification of kinematic pairs, and we will discuss constant motion. Okay, in next lecture we will discuss about what is kinematic chain and their classifications, and we will discuss about degree, how we calculate the degree of freedom of a planar mechanism. Okay, so I hope you have understand today's topic. Okay,